Welcome once again, and we will go at the pace of one lecture per day, and we will complete the entire course within 8 months, upcoming 8 months. You don't have to worry about it, but I cannot promise you, okay? I cannot promise you because I had actually promised that I will complete the entire syllabus till January 2023. The last year I had promised you regarding this, but the problem which arose is that I could not fulfill my promise. So I am really sorry for that. But this time, maybe that's why this time I am not promising you. But this time I am just making an estimate that within the upcoming 8 months we will surely cover the entire syllabus. Okay. And believe me, 15 minutes long video or 20 minutes long video will also be sufficient to complete the course within the coming 8 months. Okay. So there is no need to worry about it. Now someone had asked me on the WhatsApp that what is the proof that BJP in fact supports Manusmriti. So there are a lot of proofs regarding that. You in fact you can search the internet and see that many a times the BJP, RSS, VHP, etc. have burnt the constitution and have shouted Manusmriti Zindabad. Okay, these type of incidences have also occurred in the last 9-10 years. Okay, so leave these apart. Anyways, these things will keep happening. We will have to do our own work, but you remember one thing, that once you become the IS officer, there will be nothing in your hand. You will have to be just like a slave to the current government, because the Modi government is going to rule for the coming 10-20 years. Okay, seeing the kind of environment, I can certainly say that BJP will rule for coming 20 years or 15 years or at least 10 years. So during this period, a lot of politicization of the bureaucracy has also taken place. Anyways, we will discuss it in the some other class. Okay, some other class we will discuss it. So see, a body of mass m is thrown straight up with velocity v naught. Now there must be some diagram over here. I think there must be. No, I haven't drawn any diagram. So let us see. So there is a body of mass m. Okay, there is a body of mass m which is thrown straight up with velocity v naught. Okay, it is thrown straight up with velocity v naught, and find the velocity v dash with which the body comes down. Okay, we have to find out the velocity v dash with which the body comes down. If the air drag equals kv square, we have to find out the velocity v dash with which the body comes down at this same point. Okay, suppose I am throwing this ball from here with the velocity v naught, then it will come down over here at this particular point. Okay, it will go up and will come down at the same place. It will go up and then come down. So as it will go up and then come down, so at this particular point itself we have to find out the final velocity v dash, okay, with which the body comes down. If the air drag equals kv square, where k is a constant and v is the velocity of the body, we have to find out this. Okay, now the thing is, if suppose there was no air drag, then what will happen? Then certainly the suppose there is no air drag. Okay, if we neglect the air resistance, then if we throw the body with velocity v naught from here, then it will go up and come down with the same velocity v naught facing in the downward direction. Okay, but as there is air drag over here, so that's why the velocity with which it was thrown, the same velocity it will not acquire while coming down. Okay, velocity will not be v naught, it will be something else. So we have to find out the same. Okay, so where k is a constant and v is the velocity of the body, we will have to do, I think, 2 integrations. Let us see the answer. Okay, and remember this thing, that the k constant has been given over here, it is not assumed. Okay, it is not assumed over here. The k constant has been given to us in the question, unlike the previous questions where we had actually assumed the k constant. Okay, in the previous questions what was there, we had assumed the k constant, but over here we will not assume the k constant. Okay, it is given to us in the question. Okay, so v is the velocity of the body. Let us see. While going upward, the equation of motion of the body is given as. Now how will the equation of motion of the body be given while going upward? So while going upward, m dv by dt is there. So this dv by dt, you can eliminate this dt. Okay, you will eliminate this dt. So how will you eliminate this dt? This dt can be eliminated by the formula which I had already told you in the previous classes, that your acceleration is equal to dv by dt is there. Okay, and your v equal to what? ds by dt is there. Okay, then this particular dt from here, this particular dt, Okay, so you will find dt from here. What will it be equal to? It will be equal to ds by v, and this ds by v will be substituted over here. Then what will happen? dv divided by ds by v, which is equal to v dv divided by ds. So this is the v dv by ds. So v dv by ds. Okay, and I think some song is going on in the background, a disturbing sound, so do not pay attention to it. Okay, so from the FBD you can clearly see this thing, that this is the external force, right? The equation of motion of the body, how will it be given? This is the external force acting on the body, and that will be equal to the weight of the body, okay, and the frictional drag. So while the body is going upward, what will happen? This is the body which is going upward. This is the body which is going upward. So what will happen? The weight of the body will act in the downward direction. This is the v naught velocity of the body with which it is thrown in the upward direction. With I think it is thrown with v naught only. Yes, and the frictional drag, as the body will move upward, the frictional drag will move in the downward direction only. So the frictional drag is also in the downward direction, and the weight is also in the downward direction only. Both of the things are in the downward direction. That's why, in order to show the downward direction, we have written negative, but mg is also negative and kv square is also negative. As the body is moving upward, so the frictional drag is moving downward, because frictional drag acts in the opposite direction of motion of the object. So as the object is moving upward, so the air drag will move, apply in the downward direction, and the weight mg is also in the downward direction, and the downward direction has been taken as negative. So this is the negative sign over here. Then what will happen? You can just take this ds by variable separation. What will you do? You will basically take the v terms to one side. Okay, so this v dv is there, and over here there are v terms. So you take all these terms to the LHS, and this m, divide both side by m, that is mass, divide both side by m, and take this v term to the left hand side and this ds term to the right hand side by variable separation method. Okay, so what will you do then? This is the thing which you will get finally. Minus sign remains as it is. This minus sign has been put as it is. To calculate the maximum height h, what will you do? To calculate the maximum height h, actually you have to take the velocity from v naught. Okay, so we have to integrate separately for upward motion and downward motion. In the downward motion, what will happen? The weight mg, when the ball is moving in the downward direction, then what will happen? See, in the upward direction, when the ball is moving, this is your velocity v naught in the upward direction, then what is happening? The mg force is also acting in the downward direction, and the frictional drag of the air is also acting in the downward direction only. But when the ball will start falling down, then what will happen? Then actually frictional force of air will act in the upward direction, because it is always in the direction opposite to the motion. So frictional drag of air will act in the opposite direction, and the weight of the ball will act in the downward direction. So while the ball is moving in the downward direction, the frictional drag and the weight act in opposite direction. Okay, while the ball is moving in the downward direction, the frictional drag and the weight act in opposite direction while ball is moving downward, and while the ball is moving upward, the mg, that is the weight and the frictional drag, both act in the downward direction. So while the ball is moving, listen once again. Okay, while the ball is moving upwards, the frictional drag and the weight both act in downward direction. Okay, while ball is moving upward, and while the ball is coming downwards, the drag moves in the drag acts in the upward direction, and weight acts in the downward direction. So weight and frictional drag act in opposite direction while the ball is moving downward. So hopefully you understand this. So we have to do the separate calculations for upward motion and the downward motion, because by a single expression we cannot express them. We cannot express them by a single expression. Why we cannot express them by a single expression? Because the direction of application of air drag is changing. Direction of application of air drag is changing. That's why. To calculate the maximum height, what will you do? When the ball is thrown from here with the velocity v naught, it will reach some height h. It will reach what? Some height h. So over here the height was 0, it reached some height h. Initial velocity was v naught, final velocity was 0 over here. So upward motion completed over here. So we have basically, that's why integrated from v naught to 0 and height from 0 to h. Okay, v dv g plus kv square by m, negative of 0 to h ds. Okay, And someone had also asked whether the things which are taught in the IS institutes are those really the truth, or those are just propaganda. So the thing is, 40% of the things which are taught to you in the IS institutes nowadays, 40% of the things are actually propaganda. Why? Because the Modi government believes in propaganda. That's the thing. Okay. So as the complete media has been, 98% of the media has been completely in favor of the government. So as 98% of the media is Godi, so that's why even the IS, many of the IS teachers are also Godi. Okay. And if someone tries to speak against, a little bit against, and tries to tell the truth, he or she is forced to actually resign from the job. Okay, I was forced to resign from the job once upon a time in 2018. Okay, so leave all those things, but I am telling you these things because I am just telling you these things so that you know the truth. Okay, that writing the examination is very different, and the actuality is very different. Okay, you are not in a pre 2014 era. In those days, in the pre 2014 era, 99%, 99.9%, these kind of things were taught truly. Okay, truth was taught in most of the things before 2014, but nowadays truth is not taught. Okay, so to calculate the maximum height h, these are the things: v naught to v, then 0 to h, already explained to you. Then how will you calculate this? Let us see. So I have basically, this is the integration in which the normal physics student might, average physics student might get stuck. So in this particular integral, the normal physics student might get stuck. So by variable substitution, we are going to solve this particular integral by variable substitution method. So how will you apply that? V dv divided by g plus kv square by m. So let us multiply and divide by 2. So 2 in the numerator, 2 in the denominator. The value remains as it is. Now substitute t equal v square equal to t. So as soon as you substitute v square equal to t, so at the place of v square, t will be there, and 2v dv. Now 2v dv, if I differentiate both side by dt, differentiate both side with respect to t, what will happen? 2v dv by dt equal to 1. So 2v dv equal to dt. So this 2v dv will be equal to dt. So 1 by 2 integration dt divided by g plus k by m, v square will be equal to t. So v square is over t over here. Okay, so this is the integral which you get. Now what will happen now? Now this k by m will come out. Okay, let us take this k by m out of this particular denominator. So we took out k by m from here, and g m by k is there, and this t will remain from here. So k by m has, as it is out of the bracket, so there will be t alone. Now k by m will, the m will go in the numerator, so m by 2k will be there. Then what will happen? This particular thing is a constant, right? Now dt can be written as d gm by k plus t. Why I have written it like that? Because when you take its differentiation, what will happen? D of this quantity and d of this quantity. So this quantity, d of this quantity will vanish because it will be equal to 0, as this is a constant. So that's why I have written in the place of dt, I have written this much. Okay, so this much divided by this. So it is looking of the kind. What kind of thing it is looking at? So it is looking as dk over k. Okay, something like that. So d single variable divided by single variable. So ln formula will apply. So m by 2k ln gm by k. So dx by x kind of thing this is looking. Okay, so dx by x is ln x. So it will be ln x. So ln this much. In the place of x, this much is there. But what is there? T equal to v square is there, right? But t equal to v square, we have already substituted it in the previous step. T equal to v square. So what will happen? In the place of this t, you have to substitute v square. So you will substitute the v square over here. So this is the thing. Now we have to put the limits. Okay, because this was v naught to 0 integration, right? What was this integration? This was v naught to 0 integration, right? So you have to substitute the upper and lower limit. So substituting the limit in this particular expression, the lower limit and the upper limit. Okay, so as soon as you substitute, this is the expression which you get. Then log L minus log B equal to log A by B. So ln A minus ln B equal to ln A by B. So ln this much over this much. Then m by 2k ln this much over this much. Then what will happen? V naught to 0 this much, which was the original integral, that comes out to be equal to this much. Okay, then what will happen? We will substitute this thing, we will substitute this value over here. Where? Over here. Okay, so I have substituted that. So we substituted that value over here, and that is equal to minus integration 0 to h ds. Okay, so this is the expression which you get, and this will be equal to s 0 to h, and this minus sign we have taken to the left hand side. Okay, then what will happen? This minus sign, minus 1 multiplied by this much, then when minus sign is in front of a logarithmic symbol, when log to the base e is over here and minus sign is in the front, so minus sign can go in the power, so power minus 1 can be there. As soon as I apply minus 1 power and remove the minus sign from here, what will happen? Plus sign will come here, and this gm plus kb square, that will come over in the numerator, and gm will go in the denominator. So this is the thing which you get, and this will be h minus 0, so it will be h. So this is the thing. So h equal to m by 2k ln 1 plus kb naught square by gm. So this gm and this gm will cancel, so it will be 1 plus this much. This is suppose your equation number 1. Then what will happen? When the body falls in downward direction, the net force on it is now the case we are considering is when the body falls in the downward direction. Okay, so in case of downward direction, what will happen? The weight of the body and the air drag will act in the opposite direction while the body is falling down. Okay, so while the body is falling downward, the velocity direction is in the downward direction. What is the direction of velocity? Velocity has a downward direction when body is falling down. As velocity has downward direction when body is falling down, the weight is also in the downward direction. Okay, so weight is also in the downward direction, the velocity is also in the downward direction, but air drag will be upward. And when body was moving upward, what was happening? mg was downward, f was downward, and velocity was upward in that case. Okay, so when the body falls in downward direction, the net force on it is in the downward direction, that's why the body is falling. So mg minus kv square, this is the net force, external force acting on the body. Okay, F external, that is equal to mg minus kv square. So the equation of motion is m dv by dt equal to, now we have converted it into mv dv by ds as already told to you, and this expression will turn out to be this much. Okay, we have taken m common from here we have taken m common outside, so this is the expression which you get. Now m and m will cancel out from both the side, and v dv by ds equal to this much. Okay, v dv by ds, v dv and ds we have taken to the right hand side. This term which was on the right, this term was here, so we took it here, and this term was over here, so we took that over here. So we have separated the variables successfully. So now what is the situation? The body starts from rest while falling from the top. While falling from the top, the body starts from rest, instantaneous rest. Okay, so it will come down and down and down. Okay, and it will attain some velocity, terminal velocity v dash. Okay, final velocity, not terminal, final velocity. So this is the thing, and the distance is h. Okay, height is h, so 0 to h. Okay, we have taken this height to be 0. Okay, and this height we have taken it to be h. Okay, so it is equal to h. Or you can also take the limits like this, that this particular height is h and this particular height is 0. Okay, so from h to 0 also you can take, but in that case what you need to do is that when you take from 0 to h, you will have to actually consider this particular height as minus, so it will be minus h to 0. Okay, so you can also write from over here, you can also write minus h to 0. Okay, minus h to 0, you can also write it like that. Okay, so it will be equal to h. Why minus h to 0? Because when the body is over here, then the height of the body is minus h. Okay, this particular height, what is it equal to? It is equal to minus h. So the body will come to 0 height in some time, after some time, 0 height. Okay, so this is the thing which you can successfully do. So 0 to v dash, v dv g minus kv square by m minus h to 0 ds equal to h. Integrating and putting the value of h from 1. Okay, the value of h from where we have got? The value of h we have got from here. Okay, the value of h we have got from here, right? So we substituted that value of h in this particular expression. So substitute that value of h, we find that v dash equal to this much. And this integration, how will you do this integration? 0 to v dash integration, how will you do? This particular integration you have to do in the same manner. What kind of manner? The same manner you had done this integration by variable substitution. So in this particular integration also, you have to substitute v square equal to t. As soon as you substitute v square equal to t, what will happen? This particular term will become minus dt. Okay, this v square equal to t, so this will be minus k by mt over here, and this will be dt, not minus dt. Okay, so after you solve the integration, you get the final velocity v dash to be equal to this much. Okay, if suppose the medium is resistance less, if the medium is resistance less, then which kind of situation will arise? The 11th and 12th standard situation will arise if the resistance less medium is there, that is there is no air resistance, just like moon. Then what will happen? K will be equal to your 0, right? So this term will vanish, so v dash will be equal to v naught. So the same concept arose. Which concept? I had told you one concept, right? That if there is no air resistance, then the velocity with which you throw the body upwards, it returns with the same velocity. Okay, if there is no air resistance. But if there is air resistance, then the velocity is different. It is given by v dash equal to this much. Okay, but as soon as you substitute k equal to 0, v dash will be equal to v naught. That is your 11th and 12th standard problem it will become. Okay, so this particular thing also verifies this particular expression verifies our answer. After taking k equal to 0, we are reaching the 11th 12th standard condition of no air resistance. So that's why our expression might be correct. That's why. Okay, so this is the thing which confirms our answer, right? So thank you very much. Jai Hind, Jai Bharat. Keep yourself healthy and calm. Keep doing your work without hesitation. Thank you very much. Jai Hind.